Star clusters, cosmic families of stars. Star clusters are groups of stars that are gravitationally bound and share a common origin. They are among the most fascinating structures in the universe, providing crucial insights into star formation, stellar evolution, and the dynamics of galaxies. Found throughout galaxies, star clusters range from densely packed spheres of stars to loosely bound groups. Types of star clusters. Star clusters are broadly categorized into two main types based on their characteristics and formation. 1. Open clusters. Description: open clusters are loosely bound groups of tens to a few thousand stars that form from the same molecular cloud. They are typically found in the disk of galaxies. Characteristics: contain young stars, often only a few million to a few billion years old. Irregular shapes due to weak gravitational binding. Stars are often bright, hot, and blue, though some older clusters may have cooler, redder stars. Examples: Pleiades, M45, a prominent cluster visible to the naked eye in the constellation Taurus. Hyades, the nearest open cluster to Earth, also in Taurus. Significance: they provide insight into the early stages of stellar evolution, serve as laboratories for studying star formation and the initial mass function. 2. Globular clusters. Description: globular clusters are densely packed, spherical groups of hundreds of thousands to millions of stars, found in the halos of galaxies. Characteristics: composed of older, metal-poor stars, often over 10 billion years old. Highly symmetrical and tightly bound by gravity. Lack significant amounts of gas and dust, indicating no recent star formation. Examples: M13, Hercules cluster, a bright globular cluster in the constellation Hercules. Omega Centauri, the largest and brightest globular cluster in the Milky Way. Significance: offer insights into the early history of galaxies. Help trace the distribution of dark matter in galactic halos. Formation of star clusters. Star clusters form in regions of dense interstellar gas and dust called molecular clouds. The process unfolds as follows. Gravitational collapse. Disturbances such as shock waves from supernovae trigger the collapse of molecular clouds. As the cloud contracts, it fragments into smaller regions that form individual stars. Cluster assembly. Stars form in close proximity and remain gravitationally bound, creating a cluster. The cluster retains gas and dust, which either forms additional stars or is expelled by stellar winds and supernova explosions. Evolution. Over time, open clusters may lose stars due to weak gravitational binding and interactions with nearby objects, dispersing into the galactic field. Globular clusters remain tightly bound and survive for billions of years. Significance of star clusters in astronomy. Star clusters are invaluable for understanding the universe. Stellar evolution. Since all stars in a cluster are roughly the same age and distance from Earth, astronomers can study how stars of different masses evolve under similar conditions. Chemical composition. Open clusters reveal the chemical composition of the interstellar medium in the galactic disk. Globular clusters provide a snapshot of the early chemical environment of galaxies. Galactic structure and dynamics. Clusters trace the structure of galaxies, including spiral arms, open clusters, and halos, globular clusters. Globular clusters help map the distribution of dark matter. Distance measurement. The known properties of clusters, such as their luminosity and color, allow astronomers to determine their distances using methods like main sequence fitting. Challenges and recent discoveries. Challenges. Resolving individual stars in distant clusters is difficult. Interstellar extinction, absorption of light by dust, complicates observations. Recent discoveries. The detection of intermediate-age globular clusters challenges the notion that all globular clusters are ancient. Studies of star clusters in other galaxies, such as the Large and Small Magellanic Clouds, reveal variations in cluster properties across environments. Supermassive star clusters. Found in starburst galaxies, these clusters may be precursors to globular clusters or small galaxies. Famous star clusters. Pleiades, M45, a bright, open cluster visible to the naked eye, containing hot, blue stars. Omega Centauri, a massive globular cluster with about 10 million stars, possibly the remnant of a dwarf galaxy. Westerlund 1, a young, massive open cluster in the Milky Way containing some of the most massive stars known. 47 Tucani, a bright globular cluster in the Small Magellanic Cloud. Conclusion: star clusters are the celestial families that illuminate the story of the cosmos. From the young, vibrant stars of open clusters to the ancient, enduring stars of globular clusters, they provide a window into stellar and galactic evolution. As observational technology advances, our understanding of these stellar groupings continues to deepen, unveiling new mysteries and enriching our knowledge of the universe.